Welcome back to another episode of Math with Mr. Young. Today we're going to work with 7.6 surface areas of pyramids. Our standard is 6th grade geometry A. Our objective is that we're going to be able to represent pyramids using nets and also use nets to find surface areas of pyramids. Our mathematical literacy, we have surface area and nets. Alright, so with 7.6 surface areas of pyramids, our success criteria is that we're going to be able to draw nets to represent pyramids. We're also going to be able to use nets to find surface area of pyramids. And also we're going to be able to apply surface areas of pyramids to solve real life problems. As always, we have our mathematical literacy. Now we have surface area and we have nets. Now remember that a surface area is exactly like what it sounds like. The area of a shape's surfaces. So basically we calculate the surface area of a prism or a pyramid by adding together the area of the base or bases and the lateral faces. So basically what we do is we use a net, and a net is the surface area. So basically when we use a net, we take that three-dimensional figure and we unfold it, okay, and then we flatten it out. So what we do after that is we find the area of each face. In this case, with this square pyramid, what we're doing today, we unfolded that three-dimensional square here, flattened it out, and these blue triangles are the lateral faces, because when you fold them back together, they all meet at one vertex up top, one point, okay? And we do have a base as a square, so that's a square pyramid. So what we do, we have 1, 2, 3, 4, 5 faces. That includes the base there. We find the area for each face and add them all up. So we'll find that surface area after we do that. Same thing with this rectangular prism. What we do is we unfold the three-dimensional figure, we flatten it out, and again we have 1, 2, 3, 4, 5, 6 faces. And we find the area for each face and add them all up. That's what we do and what we mean by finding the surface area of a prism or finding the surface area of a pyramid. Alright, ladies and gents, here's our first example. Now we're going to find the surface area of a square pyramid. Again, it is a pyramid. The type of pyramid, though, is a square pyramid, because if you look at the base, you have a square. And I'm going to color that square base. We'll color it orange. Okay. So the first step, I have 3 steps here to find the surface area of a pyramid. So it's just like finding the surface area of a prism. Same steps. Step 1, we take this three-dimensional figure and make it into a net. Step 2 is that we find the area for each face. Step 3, we then add the face value together. So we add up all the faces, and then we have the surface area. All right. So this three-dimensional figure, let's take a look at this. So we have vertices, we have edges, and faces. So let's take a look at that first. Okay. Oops. So I'm gonna have you count all the vertices with me. Again, just think of it as the corners. So we have 1, 2, 3, 4, 5. We have 5 vertices. Let's count the edges now. We have 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 edges. And then we have, let's color this now. We'll color that side. There's 1, there's 2, there's 3 in the back, 4 for the front, and 5 with the base. We have 5 faces. Okay, so we have 5 vertices, 8 edges, and 5 faces. Now what we're going to do is we're going to take this three-dimensional square pyramid and we're going to make it into a net. Okay, so again, three-dimensional. One-dimensional would be, or one dimension is the y-axis. Another dimension is the x-axis. Okay. The third dimension is the z-axis, xyz. Okay, x, y, z. So these axes again, they're all one-dimensional. Okay. Oops, you don't see that. But they're all one-dimensional. So, this is the height, or the x-axis is the width, the width. The y-axis is the height. And the z-axis is the depth. Okay. So 1 plus 1 plus 1 equals 3-dimensional. So again, one dimension is your width, your x-axis, how wide. Another dimension is your height, your y-axis, how tall. And another dimension is your z-axis, okay, the depth. All right, so now that we know this is what we know, well, now that we know what a 3-dimensional figure is, let's go ahead and unfold this 3-dimensional figure into a net. Okay, so let's have the base is a square. Now each lateral face is a triangle. Okay. All right, so there's our square pyramid, but as a net. Okay, so we just took this 3D figure, we unfolded it, and then we flattened it out. Okay, so again, the base, it is a square, so I'll color that orange. Our lateral faces are in the shape of a triangle. I'll color these purple, like the Phoenix Suns color. Okay, there you go. So there is our net. Now, step 2 tells us to find the area of each face. So we have 1, 2, 3, 4, 5 faces. Okay. Now, there's measurements here. So from here to here, the width, your x value, is going to be 7 meters wide, and then our height, the y value, is 10 meters tall. So again, 7 meters wide and 10 meters tall. Okay. All right. So let's do the base first. So the base is a square, so I'm going to find the area of a square by area equals base times height. Now these variables, b stands for the base, h stands for the height. So the variable here for the base is going to be 7 meters times my height. Since this is a square, it's also 7 meters tall. 7 times 7 equals 49. So the area for the orange base is going to be 49 meters for the area. 49 meters squared. Okay. We square it because we multiplied those two dimensions. The one dimension is the base, which is the width, and then of course the other dimension is the height. Okay. Now these lateral faces are in the shape of a triangle. So half of a square is a triangle. So basically, here's the formula for a triangle. Area equals base times height. Again, half of a square is a triangle. So we divide it by 2. Excuse me. All right, so the area of this triangle here, let's focus on this bottom one, is going to be 7 meters. The height, again, is 10 meters. So 7 times 10 is going to be 70 meters squared. And then we just divide that in half. So half of 70 is going to be 35 meters squared. Okay. Now that's going to be the area just for only one of these faces. But how many faces, how many purple triangles do you see? Let's count them. 1, 2, 3, 4. So each of these is 35 meters squared. Okay. Each purple triangle. So you can add them all together. 35 plus 35 equals 70. Again, 35 plus 35 is 70. And 70 plus 70 is going to be 140. Or you can just multiply by 4. By 4 purple lateral faces. Okay, now 4 times 5 is going to be 20. 4 times 3 is 12. plus 2 is going to be 14. So 140 meters squared is going to be the total area for all of the purple triangles. And then to find a surface area, step 3, we add each face together, each face value together to get the surface area. So all we got to really do here is just add 49 plus 140. And 49 plus 140 is going to be 189. So the surface area equals 189 meters squared. So the surface area for this whole three-dimensional square pyramid is 189 square meters. And that's all we do. Again, just let's recap. Step 1, we take this three-dimensional figure, unfold it, and flatten it out into a net. Once we see that, we find the area for each face. Okay, all the faces, find the area for each one. Use the square formula, square area formula for a square. Uses the triangle area formula for the triangles. Okay, and then we add all the face values together to get this total surface area of that three-dimensional square pyramid. All right, there we go. All right, so moving on, we're going to find the surface area of a triangular pyramid. To be honest, it is the same method. Boom, right there. So step 1, you're going to unfold that three-dimensional figure into a net. So unfold and flatten it out. And then you're going to find the area for each of the faces. And then after you find the area for each face, you're going to add them all together. Add each face value together to find the surface area of that triangular pyramid. All right, one more time. So we're going to find the vertices, edges, and faces of this three-dimensional figure, that triangular pyramid. Okay, so first thing we're going to do is we're going to count all the 0 dimensionals. So we're going to count all the corners that have no dimensions. So we have 1, 2, 3, 4. We have 4 vertices, 4 corners, 4 points. Now we're going to count all the 1 dimensionals, all the edges. Okay. Now these 1 dimensionals, you have your x-axis, y-axis, and z-axis. We're either going to count the width or the height or the depth. 1 plus 1 plus 1 equals 3 dimensionals. I want you to understand what 3D really means. So let's count all the 1 dimensionals, the edges. Okay. So we have 1, 2, 3, 4, 5, 6. We have 6 edges. And then count all the 2 dimensionals. Again, you're going to have a height and a width for these dimensionals. So if you look at the base down here, what shape is that? Well, I'm going to color the base green. And you have a triangle, which is why this is a triangular pyramid. It's still a pyramid, but the base is the shape of a triangle. And that, my friends, is what makes it a triangular pyramid. So we're going to count all the lateral faces. So we have 1 in the back, 2 on the side, and 3 here. Okay, do you guys see that? So again, we have 3 lateral faces plus the base, so that means we have 4 total faces, 4 total 2 dimensionals. So again, I'm going to color these guys. I'll color the back one first, and then the left side, and then the right side. So I'll color the lateral faces purple. All right. So the first step is that we're going to have to unfold and flatten this three-dimensional triangular pyramid into a net. Okay. So here we go. There's our base. It's a triangle, which is why it's a triangular pyramid. And then we're going to unfold the lateral faces. Here we go. Okay, I'm just sketching. There you go. So there is our net. So step 1 is completed. We unfolded and flattened that three-dimensional figure into a net. Next, we're going to have to find the area for each face. Let me color code these. Again, this is the base. Okay. Oops. I was supposed to color it green, but that's okay. And then the lateral faces. Okay. So again, we unfolded that three-dimensional figure into a net. Now, if we were to take this lateral face, fold it, this one, fold it, and this one, bring it in. They're all going to meet right here at this point, that vertex, okay? That single point. All right, so we do know that the base here is 6 feet. All right, and the height is 8 feet. So we know that these lateral faces, they are 8 feet tall. And the base value for each base is 6 feet. All right, so this geometrical shape is a triangle, so we're going to use a triangular or the triangle area formula. Got tongue twisted there. So area equals base times height divided by 2, or you could use area equals half times the base times height. Basically, it's the same thing. All right, so check this out. The base here is 6 feet. The height is 8 feet. Okay, and then we divide that in half. Area equals. Now 6 times 8 equals 48. So this will be 48 feet squared. And then the last step is to divide it in half. Half of 48 equals 24. So each face is going to be 24 square feet. So this would be 24, 24, 24, 24. All right, there you go. Now, how many triangles do you have? You have 1, 2, 3, 4. 4 triangles. So you just multiply by 4. Okay, by 4. All right, and then 24 times 4. Let's see here. 24 times 4. Let's see. 96. This will be 96 feet squared. The surface area is 96 square feet. Oops, can't see that. All right, there you guys go. So again, step 1 is you unflatten, or you unfold and flatten the 3-dimensional figure into a net. Step 2, you find the surface area for each face. Step 3, you add each face value together to find this total surface area of the 3-dimensional figure. In this case, this is a triangular pyramid. All right, my friends, there you go. So 7.6 surface areas of pyramids. By now, you should be able to draw nets to represent pyramids. You should also be able to use nets to find surface area of pyramids, and again, to apply surface areas of pyramids to solve real-life problems. All right. So again, please ask for help. Let me know if there's something that's confusing, and I will do the best of my ability to help you guys out. All right. Have a good day.